Hi, this is Ms. Sherbin, and as you can see, I'm on a train. I promise I'll get you these videos, so I'm going to make them on my way to Boston. So, this is lesson 22, Geological Evidence, questions 1 through 18. And we're going to start off with number 1. But please remember you can pause, rewind at any point that you would like. And that the answers don't need to be exactly the way I write them. They should be in your own words, but they should get the gist of what the answer was saying. So the first question asked, how do sedimentary rocks form? And if you didn't understand this question or you had difficulty with it, I went over it a lot and even gave you some other videos in the original video for this lesson, the guided instructions, so feel free to use that. Alright, so number 1, how do sedimentary rocks form? Small particles of clay, dirt, and sand collect in the bodies of water and harden sedimentary rock. So basically, because of weathering erosion, they break up and then they sink to the bottom, and then over time they're going to get like pushed together and they're going to create rock. It takes a long time. Number 2, compare and contrast the ages of fossils found on top and bottom layers of the ocean floor. The fossils found on the bottom layer are older than the fossils of the top layer. This also means that the fossils on the top layer are younger than the fossils on the bottom layer. Number 3, what factors influence why species evolve? So if you needed help with this question, please go back and review lesson on natural selection. I believe that was lesson 21. And it's a very important lesson. Alright, so what factors influence why species evolve? Well, if there's a change in the environment, the species that are adapted to that change are going to go on to survive, and the species that aren't adapted to that environment are not going to survive. So sometimes there's a genetic mutation that favors that change, and those species or those organisms within that species will go on. Basically, environmental changes causes species to change. So species evolve over time to adapt to changes in their environment. Number 4, why might a species with a short lifespan evolve more quickly? Now this was a question that was very important to the reading and very important to the rest of the questions coming up. So most generations with a shorter amount of lifetime, like say like this much lifespan, distance was lifespan, alright, are going to change only about every generation. But since their amount of generations probably can fit into like this much of our lifetime, they're going to change quickly. So species with a shorter amount of lifespan will show more changes more quickly than species who reproduce slowly. That means you can go through a lot more generations and you have a lot more of those changes. Number 5, imagine you're a scientist searching for fossils for ancient sea animals. As you begin digging in the bed of sedimentary rock, you find more and more fossils. What do you notice about the fossils you dig deeper and deeper into the rock? Well, back at this one, we said the fossils at the bottom of the rock are older than the fossils in the top layers. So let's imagine that this is our what we've been finding. Let's say that these diagram is what animals look like almost today. And as we go deeper and deeper, we find that it's 1, older, but 2, they look less and less like what we saw in the youngest layers. So the fossils are going to become more unlike present-day sea animals because they're older and they took all that time to evolve into different creatures. So the older the fossils are, the more likely they'll be less like what we see today. Number 6, how might you account for the fact that fossil seashells have been found on high mountain slopes? Well, they have actually found seashells on the top of Mount Everest, and no, hikers did not bring them up there. But what happened is that plate tectonics once did not form a mountain, and it once was covered by the sea. And slowly over millions of years, the plates pressed forward and they created a mountain. And the fossils that were there once on the bottom of the seafloor were pushed up to the top of the mountain. Alright, now questions 7 through 10. These are really good questions and important, but they didn't really align too much to what the reading said. So if you got a little confused or lost, it has a lot to do with scientific method. So it's really important that we go over it now. Alright, directions 7 through 10. Directions are important because they tell me what questions that all this stuff belongs to. For each question, write your answer in the space provided. Base your answers on questions 7 through 10 on the paragraph and graphs below. Alright, so 7 through 10. Alright, antibiotics are drugs that are used to kill bacteria. Alright, so antibiotics kill bacteria. Some bacteria have a resistance to certain antibiotics. So some bacteria are resistant, meaning that antibiotics have no effect on them. If a person is infected with these bacteria, antibiotic drugs will kill other bacteria, leaving only the bacteria with resistance. Antibiotic-resistant bacteria continue to reproduce and cause disease. The bacteria that cause tuberculosis are one of the examples of bacteria that have become resistant to some antibiotics. So that paragraph told me is that sometimes antibiotics don't kill the bacteria, and the ones they don't kill go on to reproduce. And there's actually a real-world example of this. The bacteria that causes tuberculosis isn't reactive to bacteria. The following graphs summarize data from a study testing the effectiveness of 3 antibiotics on a strain of bacteria. To see how bacteria grew naturally, one sample received no antibiotics. So one sample received no antibiotic, and it was testing the effectiveness of 3 antibiotics on bacteria. So if I look at my graph, I can see the number of bacteria and the type. So this says no antibiotic. And what I can see is that it's increased, right? Antibiotic A also is increased. That's no good. Antibiotic B has seemed to decrease. Antibiotic C seemed to first increase, decrease, and then, whoa, increase again. Okay, so make sure that you have those drawings in there. I'm going to do them again. They increased. A, no bacteria increase. Oops, A also increased. B decreased overall. Then C decreased and then increased. Okay, so make sure you have those notes. It's really important you mark it up. It helps make it disprove. So number 7, in the experimental setup, what term is applied to the sample that received no antibiotic? Why was this test included? Well, if you go up to here, see up here, it says to see how the bacteria grew naturally, one sample received no antibiotic. It doesn't tell you what that's called. This is something that the reading did teach you and that we went over a long time ago in class, so let's go back to it. The sample is the control or control group, and see how bacteria grew naturally. A control or control group is one where the experimental condition is not applied to see what will happen with the factor being tested. So we do the one with no antibiotic to see what the bacteria will do naturally, to see, maybe we can see that antibiotic A had a little bit, just a tiny bit of effect on it, but not enough where we actually want to use it as a cure for the bacteria. But we know that it did have an impact because we did do the control. Okay. Number 8, explain why antibiotic had the least effect on bacteria. We'll explain which antibiotic. Okay, so if I look over here, we know that this was what it looked like if there was no antibiotic, but antibiotic A is the one that has the bacteria grew the most. It looks like it didn't have much effect. So antibiotic A has the least effect on the bacteria. The graph of A is similar to the graph of the bacteria that received no antibiotic. If you had a disease that caused the bacteria If you had a disease that was caused by bacteria used in a study, which antibiotic would you want to be treated with? Explain. Well, I know for me, I don't want the one that kills the bacteria. So look over here, A is the only one that really made a decrease. So antibiotic B was effective in killing bacteria. The evidence is in the graph. Number of the bacteria decreased. So there's our evidence. Question 10. Explain the results obtained when bacteria were exposed to antibiotic C. So we know here that it kind of increased, decreased, and then increased again. This one was kind of like just a normal rate. But so basically what I'm going to talk about is here in here because that's where the effect took place. At first, the antibiotic killed the bacteria, but some were resistant. So, see these that didn't get killed, the ones that these amount of bacteria that didn't die, they were resistant. Okay, they survived and reproduced. Their offspring showed resistance to antibiotic C and probably had the genes necessary to survive and reproduce, and that's why they increased. Okay, alright, so now it's time for multiple choice questions. Alright, number 11, most fossils are found in, not all are found in lakes and oceans. If you think about it, we find them in Egypt a lot. Like we find them in other aspects of the world too, like not always in land. So it's 2, sedimentary rock, and it's not always the top layer of the rock, and rivers and streams definitely not. All right, in the picture below, which rock layer is the youngest? Well, we know that the top layer is the youngest and the one's oldest, so 1 is the youngest. Okay, number 13. How does the age of a fossil compare to the age of rock layer in which it is found? It's the same. The rock layer is made at the same time that the fossil is, and that's how a lot of scientists are able to date fossils. All right, which of these animals is most likely to evolve most slowly? If you think about it, housefly, we read, has like a lifespan of like just a few days. Human, we can live up to 100 years, even longer, and it takes us like a decade, 2 decades to reproduce. A dog, we ever heard of dog years and how dogs are like older than us? And a butterfly only lives for a few days. So the human is the one that's going to evolve most slowly. All right. Number 15. Oh, and this is our time for our secret word. Our secret word is fossil. All right. Number 15. What is the first step in the formation of sedimentary rock? And it's number 4. Small pieces of rock break off. You need the sediments to make sedimentary rock. All right, 16. Antibiotic resistant among certain bacteria is an example of evolution. And it's a really good example of it because we can see it happen like in real time. We need to wait several decades to see it happen, or millions of years like our evolution took. Number 17. Which best explains why some type of mosquitoes have become resistant to insecticides? Insecticides are not strong enough? Nope. They wouldn't have become resistant. The same area could not be sprayed by more than one insecticide unless there's a law against it. I mean, you can spray whatever you want, however long you want. It's not good, but that's not why all these different mosquitoes have resistance. Mosquitoes have a short lifespan, yes, because they're going to evolve more quickly. They're going to evolve to be resistant against insecticide. Number 4, mosquitoes can't live in more than one environment. They're all over the place. So that can't be it. 18, how might evolution most likely be harmful to humans? An organism can evolve that is smarter than humans. That does not really threaten our evolution. 2, an organism that causes a deadly disease can become resistant to our medicines. Yes, and that is actually a big fear of medical professionals. That's why we promote not using antibiotics all the time, because eventually it will become resistant if everybody's using antibiotics for every single cold, every single sickness. Number 3, new plants can evolve that are resistant to pesticides. I mean, that can be a nuisance, but it's not going to affect our survival. And number 4, evolution can never be harmful because it happens too slowly. Wrong. Bacteria can happen pretty fast. All right, and that concludes our video for this lesson.